Hello everyone, myself Snehal Shinde, lecturer in Pravin Patil College of Diploma Engineering and Technology from Electrical Department. Subject is Utilization of Electrical Energy. Subject code 22626, Unit 2, Electric Heating and Welding System. So now we will study vertical core type induction furnace. It is also called as Ajax vac furnace. So according to the construction, it consists of a transformer with the horizontal core and a vertical channel for the charge. Secondary is formed by the charge itself. Comparatively better magnetic coupling between primary and secondary is obtained due to the V-shape, so the odd-shaped crucible is avoided. In the upper portion, inlet is provided for the charge, outlet for pouring the molten metal is also provided. Mechanical geared fitting is provided at the bottom of the furnace. Refractory line is provided to reduce heat loss. Operation is the V-shaped channel is always filled with the molten metal. The total melt is never drained out from the furnace even if the furnace is not functioning. A low voltage is maintained across the primary with the help of autotransformer which circulates current and thus keeping the charge in the molten stage. Now the additional charge to be melted is poured in the furnace. Then primary is given AC supply, causing the heavy current in the material housed in the V channel. Thus, heat is produced which is utilized for melting the charge. The circulation of the molten metal takes place in V channel due to convection. The high temperature metal goes up and low temperature metal comes down. Thus, the steering action is automatically obtained. This causes the homogeneous heating and used up to 2 tons commercially used for melting non-ferrous metals like copper, brass. And the advantage of Ajax vat furnace are, as the furnace has narrow V-shape crucible at bottom, so small quantity of molten metal remains in the narrow V notch from the previous operation, which will help to keep secondary short circuited. So no extra care is required to start the furnace. Magnetic coupling between secondary and primary winding is better because both windings are on central limb of magnetic core. So there is the less leakage flux. Hence, leakage reactance is less, so power factor is better than the horizontal crucible direct core type induction furnace. Due to pinch effect in ordinary core type induction furnace, there are chances of temporary interruption in the secondary circuit when current density exceeds above 500 ampere per meter square. But in this type of induction furnace, there are no chances of interruption in the secondary circuit even if current exceeds 500 ampere per millimeter square, because tendency of weight of charge keep in contact due to narrow V-shape. So we can increase current density above 500 ampere per millimeter square to obtain more heat in less time. Vertical crucible is always better than horizontal crucible for pouring and taking out the metal. Also, space required is less as heat is produced directly in the charge. There is no heat transfer loss. So the efficiency of a furnace is more as heat is directly produced in the charge. Time required for melting metal is less, so energy consumption is less as the current is directly induced in the charge. There is automatic steering action taking place in the charge due to electromagnetic forces developed in the charge, due to which through mixing of molten metal is possible, uniform heating is possible. Temperature can be controlled easily. Next is the coreless induction furnace. It is also called as the high frequency induction furnace. It works on the principle of transformer. The primary winding is wound on surface and it is connected to the AC supply. The charge inside the furnace acts as secondary. The induced current heats up the charge and due to the skin effect, primary winding gets heated up. To keep the coil temperature within the limits, these coils are made hollow and water is circulated through it. Heat in the charge is produced by eddy currents flowing concentrically. High frequency supply is preferred 500 to 1000 Hz because eddy current is proportional to B square F square. With this method, it is possible to employ vacuum heating required for heating precious materials. Power factor of this furnace is very low and efficiency is very low. Stray magnetic field produced by coil outside the heating coil may link with the supported steel structure and causes serious heating to the supporting structure. To avoid this, external packets of the laminated core are provided which provide less reluctance path for magnetic field. This also decreases magnetizing current and increases the power factor. Sometimes capacitors are used to improve the power factor. Advantages is time required for melting is less, temperature control is easy, shape of the container and crucible is simple and suitable. Automatic steering action is obtained due to the eddy currents, and the advantage is the overall cost is the less. So this was the working of the coreless induction furnace. Now what are the applications of the induction heating? So induction heating is employed for various industrial applications such as soldering, brazing, heat treating, including hardening, annealing, melting, sintering, powder metals, drying paints, sterilizing surgical instruments, bonding, clutch facing. So the application is melting of steel and non-ferrous metals at temperature up to 1500 degree Celsius, heating for forging to temperature up to 1250 degrees Celsius, annealing and normalizing of metals after cold forming using temperatures in the range of 750 to 950 degrees Celsius, surface hardening of steel and cast iron work pieces at temperature from 850 to 930 degrees Celsius. Tempering is 200 to 300 degrees Celsius. Soft and hard soldering at temperature up to 1100 degrees Celsius. Moreover, special application such as heating for sticking and sintering. So here we have completed the induction heating, that is the core type, horizontal and vertical, and the coreless induction furnace, its advantages and its disadvantages, and the application of it. Thank you.